Hello! Hiya. I've recently had a request from a subscriber to create a video showing how to answer 6-mark questions. So I've pulled a few questions together. I can't guarantee that these will be on your exams, but the Edexcel Advanced Notice article says there's a chance. I've noted next to each question which tier and course the question is relevant for. Just use the chapters under the video window or the timestamps in the description to jump to the questions that are relevant for you for the June 2022 exams and beyond. Also note that one of the 6-mark questions is for a required practical that the 2022 Advanced Notice article states will be asked about on the June 2022 Edexcel Physics exams. A link to my video for the other required practical can be found at the top of the screen now. I recommend you watch it. I have a past paper playlist that's really helpful for revision for paper 2 that I'll put a link to at the end of this video. Right, let's get started and good luck. Question 1. Explain with the aid of a circuit diagram the method a student could use to investigate how the resistance of a single lamp changes with the potential difference across the lamp. Okay, if we're going to get the resistance of the lamp, we need to calculate voltage and current. Voltage is measured with a voltmeter and current is measured with an ammeter, so we need to incorporate those into the circuit. And they're asking about how the resistance changes, so we need some kind of way of changing the voltage and current. So the first thing we need to do is measure the voltage and measure the current and work out the resistance. Then once we've done that once, we will change the size of the variable resistor, which will give us another voltage and current reading to compare. So you want to compare the original voltage and resistance of the bulb to the new resistance and determine the relationship. For example, if at first you make the variable resistor small, that means that the voltage on the bulb will be big. And you'll find out what the resistance will be. Then what you do is make the variable resistor big, and that'll make the voltage on the bulb be small. And then you see what the resistance is. Compare this first resistance of the bulb with the second resistance, and you'll be able to see, as the voltage got smaller, what happened to the resistance. Question B. The photograph shows a temporary traffic sign. The traffic sign uses many small lights, all powered by a rechargeable battery. These lights need to be very bright during the day so they can be seen clearly. They do not need to be as bright at night. Explain how using a light-dependent resistor can make the energy stored in the battery last longer. Okay, let's compare the LDR during the day and what's happening at night. During the day, the LDR resistance is low, which means that the current in the circuit is high, which means that the battery is using lots of energy, which means that the bulbs are very powerful. Power equals energy transferred over time. So if you're using lots of energy per second, it's going to be very powerful. It's always good to back up your answers with a calculation if possible. If the bulbs have got lots of power, it means they're very bright. And that's what it needed to be during the day. Now let's compare that to at night time. At night time, the LDR's resistance is high, which means that the current will be low, which means there's not much energy being used. If you wanted to back that up with an equation, use this. Emmerdale is on ITV, which is energy is current times by time times by voltage. So if the current is less, then the energy will be less. Now the bulbs won't be very powerful, but that's absolutely fine. They don't need to be as bright at night. Now although we won't get a mark for saying that because it's already said here, we can now go on to say that the battery is using less energy at night, so the battery will last for longer. Now I've marked lots of exams over the last 22 years, and I'm quite happy if a student gives me an answer structured like that, with the use of a table. I quite like it when the students put their answers down as bullet points, because it shows me that they're expecting a mark for each one of these. Not all the time, remember, with regards to that statement, but most of the time. And besides, even though it's worth a 6-mark question, they've got a lot more than 6 marks there, so they'll easily get the 6 marks. Question 7. Figure 20 shows the 3-pin plug used to connect the kettle to the mains. The fault occurs in the kettle, causing the live wire to touch the metal case of the kettle. Explain how the safety features of the plug operate when this fault occurs. I've got a lovely video all to do with the earth wire that'll show you how to answer this. There's a link at the top of the screen now. Now the answer's always the same, so for 6 marks this is how to answer it. If the live wire becomes loose and touches the metal casing of the kettle, this will cause a short circuit inside the kettle. So what that means is that there'll be much less resistance inside the kettle. Because there's less resistance, the current will increase. Because instead of the current going around a high resistance filament inside the kettle, the current will simply pass through the earth wire, which has got very low resistance. Now because there's so little resistance in the circuit, that'll cause a high current. Now remember, before the current goes through the live wire, it's got to go through the fuse. If suddenly there's a big current coming in, that'll blow the fuse. Because the fuse, remember, is a thin wire with a low melting point. And if you've got a large current, that causes the wire to get hot, which melts the fuse wire and breaks the circuit. If you haven't got a clue what I've just said, seriously, watch my video about the earth wire and double insulation. It'll also explain to you why you don't need an earth wire if the kettle is not metal. A lot of kettles have got plastic casings. That's a common question, you can't afford to get it wrong, so make sure you check that video out. Question 3. The diagram shows a model used to generate electricity from water waves in a tank. A ball floats on the surface of the water in the tank. A coil of wire is fixed to the floor of the tank. A magnet is suspended from the ball inside the coil. When a wave is sent along the surface of the water, the ball moves up and down. Right, so the ball's floating on the top of the water. Right, this is all the water here. Now, as the ball goes up and down, the magnet's going to go up and down. inside the coil of wire. And that's going to create a current, as shown here. Explain how this current is induced in the coil in the model. You should refer to the model and to the labelled points on the graph in your answer, and it's worth 6 marks. Right, you're going to get a current created when the ball is moving, because that's going to make the magnet move. If the magnet isn't moving relative to the coil, you're not going to get any current. Now, as the wave comes past, first of all, the ball's going to move up a little bit. So then you're going to get a little bit of current. Then the ball's going to move up a bit more. Now, the faster that the ball's moving, the more current you're going to get. So at this position here, that must be when the ball is moving fast. Now, as the wave comes past, when the wave is at its peak, that ball is going to be at the top of the wave, and just for a split second, the ball isn't going to be moving. So that's going to be at that position there, when the current is nothing. So that's going to be the top of the wave. This will be at the middle of the wave. And then as the ball starts to come back down, as that wave passes, the ball's going to start to come down. So if the ball moves up, what we've got is a positive current. Then as the ball moves down, you're going to get a negative current. This part here is when the ball is going to be moving at its fastest. That's when you're going to get your biggest current. At this point here, when the current is nothing again, that's when the ball is going to be in the trough of the wave, which means the lowest part of the wave. So conceptually, that's quite a tricky question, that. Question 7. High voltage transmission cables and transformers are used in the national grid. Explain how using high voltage transmission cables and transformers allow the distribution of electrical power around the United Kingdom to be as efficient as possible. Refer to the following equations in your answer. Right, as soon as you see about efficiency, you know you need to reduce wasted energy, or in this case, wasted power. So the whole thing about the transmission, right, if that's your power station there, what you need to do is use a step-up transformer here before it gets to the pylons. You need to transmit the voltage at high voltage because that will reduce the current. And then you need to remember to step down the voltage at the end before it gets to your house. Now you do need to know these values, so 25,000 volts there. Then what they do is they step it up to about 400,000 volts here. So that's basically 16 times bigger voltage. Now what that does is it makes the current go 16 times smaller. Now if the current's 16 times smaller, that means that the wires are going to be much cooler, because current makes the wires get hot, which creates what we call line loss, which is losing your electrical power as heat in the wires, and it goes off into the atmosphere. Now you need the step down transformer at the end, because you can't put 400,000 volts in someone's house. 400,000 volts is a very high voltage. It'll cause sparks, which are dangerous. Now I haven't talked about this equation yet. Now if you've got very long wires, remember wires have got resistance. So because this is a really long wire, it's going to have a really big resistance. Now if your resistance is massive, that means that your power loss is going to be huge. So there's not much you can do about the resistance of the wires. We can make the wires, with as low resistance as we can, and make them nice and thick to create the resistance being low as well. But at the end of the day, it is what it is. So one way that we reduce the power loss is by reducing the current, and that's where the step up transformer at the start and then the step down transformer at the end comes in. Right, I'll show you how to write that. Alright. Right, I forgot to use that equation, but it just pops in here. So what it means is if you make the voltage on the secondary massive, means you can make the current small. So on here, you'd have the voltage would be little and the current would be big. And then on this one, you'd have the voltage would be massive and the current would be little. So that's on the step-up transformer. So remember, that's the primary coil there, and that's the secondary coil there. I find I'm very waffly doing this today. Sorry about that. I think it's just with the exams coming up soon. I'm just wanting to make sure that you get all the detail correct. Number 7. Figure 16 illustrates an effect that can be explained using the ideas of pressure, force and area. Explain why the tip of the drawing pin goes into the wood, but the head of the drawing pin does not go into the thumb. Right, let's have a look at the pressure here. Pressure equals force over area, right there. And here, pressure equals force over area. Now the force is going to be the same in each case, because this person is providing the force going downwards. So the force here will be the same as the force there. However, you can see at the head of the drawing pin, it's a large area. If you divide a number by a big number, you'll end up getting a small number. So what we've got is we've got a small pressure. Now what I like to say is that the force gets spread out over a large area, and that's what creates the small pressure. Now if you've only got a small pressure on the thumb, it's not going to damage the thumb. Let's do the same analysis on the tip. So once again, the force is the same, however this time the area is very small. Now if you do a number divided by a small number, the number you get is still going to be big. So that's going to be a large pressure. The way I like to think about it is that the force gets concentrated in a small area. It doesn't get spread out over a large area, it's getting concentrated in a small area. And what that does is it makes a very large pressure. I've actually got a nice little video that I do a demonstration on me son a couple of years ago. Check it out. I'll put a link at the top. Now how do you write that down to get the 6 marks? Just like this. Okay, I've saw questions asked like that about why is a camel's foot nice and wide. In this case, it's so it doesn't sink into the sand because it's got a large area and the force gets spread out, so there's a small pressure. So these questions are always the same type of pattern. And the more of these questions you practice, the more you'll realise that. And that's the last question. So I hope that was useful for you. The more of these questions you do, the better you'll get and the more success you'll have on your exams. Work hard, be nice, subscribe to my channel, and I'll see you in the next one. Good luck with your exams.